Welcome to another video for General Science. In this video, we're going to be discussing acceleration. These are some of the topics that we're going to discuss in this video. Number one, how are changes in velocity described? How can you calculate acceleration? How does a speed time graph indicate acceleration? That particular point, I'm actually going to make a separate video where I compare the graphs of speed, velocity, and acceleration. And then what is instantaneous acceleration? Throughout this video, I have sprinkled some videos that illustrate these points just to kind of help us to kind of get a view of what's actually happening. So let's look at the first one. How are changes in velocity described? So velocity is a description of both speed and direction of motion of an object. It's a vector. Okay, so it has magnitude and it has direction. That little triangle that you see there and that next to on the left of the V is a delta. Delta V representing the change in velocity. So the change in velocity, the formula is represented by distance over time, meters over seconds. Okay, so it's a matter of how much distance has been covered or changed over a specific amount of time. Now with acceleration, which is what this video is about, it adds another dimension to this because, again, with velocity, it's distance over time. Well, with acceleration, you replace the distance with v, and it's actually a function of v, delta v over time. So the rate at which velocity changes is called acceleration. And this is actually a truer form or a truer way to describe the motion of an object because in reality, when something is moving, it does not remain, for the most part, it doesn't remain at a constant speed. There's typically fluctuations in its velocity throughout its journey. Sometimes it's going a little fast, sometimes it's going a little slow. All right, so it's represented as delta v, the change in velocity over time, which can also be signified as, since it's a change in velocity, you want to know the final velocity of the object and then minus the initial velocity. This is a way that you can get average acceleration. Okay, so acceleration again is a vector quantity, and this particular equation you see right now is for average acceleration. Okay, so how much velocity, how has the velocity changed over time? So changes in velocity can be described in two ways. Number one, changes in speed and changes in direction. Both of those indicate an acceleration. So if any of these two happen, then the object is technically accelerating. Acceleration is often used to describe situations in which the speed of an object is changing. And like I mentioned before, in a journey, in a path from point A to point B, there are typically fluctuations in how fast the velocity of the object is going. Okay, so here I have a video of a rocket ship taken off, and every second that goes by that this rocket is propelled forward, it's accelerating. In other words, it is covering a different amount of ground, a different distance every second. And as every second goes, if it's accelerating, it's covering more distance over time, which means it's accelerating. So this is not traveling at a constant rate. It's not traveling at the same speed every second that goes by. As every second that goes by, it's accelerating more and more and more. And it'll eventually reach something called your escape velocity, which means a velocity that's fast enough. You can see here, it's about to break the sound barrier. You can see the kind of the plumes right there. You just saw it. It creates that mist, that plume that is typical of something breaking sound, which means is that now it is traveling faster than the speed of sound. Okay, so it needs to gain a certain velocity to be able to escape the Earth's gravitational pull, the Earth's atmosphere, but that's for another video. Okay, all right, so let's continue. So what happens when the object's velocity stays the same? So there is no change in velocity, or velocity is now constant. If the velocity is constant, that means the velocity final will be the same as the velocity initial, which means your numerator will be 0. So velocity is no longer changing. That means there is no velocity anymore. Now, does that mean that the object has stopped moving? No, the object is actually still moving. It's just moving at a constant rate, which means it's no longer accelerating. It's not going faster or it's not going slower. So that means anytime you have a 0 in the numerator position, that means your number in general is a 0, which means there is no acceleration. And that's okay, that happens sometimes. So what happens if the object slows down? Well, that means that your initial velocity is greater than your final velocity, which means you're going to have a negative number, okay, a negative velocity, which means there's a negative acceleration. Okay, so if there's a negative acceleration, that's okay. All that means is that the object is accelerating in the opposite direction that it's moving, which means it's decelerating, it's slowing down. It's the same thing that happens when you're approaching a stoplight. Okay, when you're approaching a stoplight, you're slowing down. Okay, you're still accelerating, but you're accelerating in a negative direction, and you feel that as you're driving. Okay, so the rate at which velocity changes is called acceleration. Okay, changes in speed, so it can go fast, faster, or it can slow down. Okay, either one is accelerating. All right, so here I have another video, Usain Bolt. So at t.6 seconds, okay, Usain Bolt is accelerating. He's going faster than his initial velocity. And as every second that goes by, Usain Bolt is continuing to accelerate. So his velocity is changing over time. His velocity is increasing. And as you can see, it's increasing faster. He's accelerating faster than anybody else on that track. And at this point, he's probably reached his peak velocity, which means he's no longer accelerating. Okay, so he's reached his peak speed and he won, and now he's slowing down, which means his velocity is decreasing. His velocity is negative. Okay, so he's still changing speed, but it's just going in the negative. Okay, so again, notice how he pulls away from the other runners. That just means he has more power. He has a stronger acceleration than the other runners. He's accelerating faster than anybody else, and now he's decelerating. Now it's a negative acceleration. All right. Okay, let me show you another example of acceleration here. Yeah, we know this particular acceleration. We call this gravity. Okay, gravity, as you know, is a physical force that pulls you down towards the center of the Earth. And this is a function of the amount of mass the Earth has, which increases its gravitational pull, and it pulls objects towards its center. Now, it pulls objects at a constant rate, 9.8 meters per second. So as this person is falling, gravity is pulling him down at a constant rate, and now you can tell there that his arms are kind of flailing up and his hair is being pulled up. That's air resistance at work against gravity. But of course, it doesn't have enough force to maintain him up. Gravity is just too strong. So every second that he is falling, he's actually falling faster and faster and faster. And he's falling faster and faster and faster at a constant rate, which is 9.8 meters per second squared. Okay, so he accelerates at a constant rate. So you can replace acceleration A with g, little g, gravity. Okay, now I have negative 9.8 meters per second squared. Again, whether it's positive or negative is completely arbitrary. It all depends on your frame of reference. Okay, it can be a positive integer or negative. It's up to you. Now, free falling. So free fall, again, you're being pulled by gravity, and eventually you get to a point where you are no longer accelerating. You're actually falling now. Your velocity is at a constant speed or constant rate, and we call that terminal velocity. Terminal velocity means you are no longer accelerating towards the ground. You are now just falling at a constant rate. Okay, but again, you notice that you're still falling. You're just falling at a constant rate, which means there's no more acceleration. There's no more little g. Okay, and again, you can notice as these guys are falling that there's still air resistance that's working against them. So if your v is constant, then your v final and your vi are 0 or is 0, which means no acceleration. So the next principle that you're going to see here on this video, you're going to notice that the air resistance, so you see the parachutes? The parachutes, as they open up, they are increasing the surface area of the object. And if you increase the surface area of the object, you are also increasing the amount of space that air resistance can work on. So if you increase that space, that actually causes you to slow down considerably. Now, you know that if you're slowing down, that means you're accelerating, but you're accelerating in the opposite direction, so you're going slower. So again, air resistance or surface area increases, air resistance increases, it can play a bigger role, and it can push you up higher, and it can slow you down. But again, gravity still overcomes and pushes you down towards the to the earth. Now finally, I have a third little video here for you. This one I'm going to illustrate instantaneous speed. So just kind of recall the last time your mom or dad dropped you off at school and you were late. So the velocity that you're going to school is is much faster maybe than in a regular morning. And what I'm illustrating here is instantaneous speed. What is that? Instantaneous speed is the instant. Okay, so when you're driving, or when you're in the passenger seat, mom and dad are driving, and you look at the speedometer and it's 130 miles per hour. Well, at that very instant, we call instantaneous speed. You are going that fast at that instant. So every time that you look at a speedometer, you're actually looking at instantaneous speed. You're looking at the speed that you're going in that very instant. Now again, as the trip goes on, you might slow down, you might go faster, but every time that you peek over to that speedometer, you're taking a look at instantaneous speed. Okay? All right. Safe traveling when you go to school. Don't go this fast. All right, well, that does it for acceleration. I hope you enjoyed this video. Thank you for listening and watching, and good luck in your studying.